All right, class, if you notice, today we're going to start Chapter 7. And Chapter 7, if you're on page 286 in your book, is all about applying fractions. So fractions haven't gone away. We're going to do the first few things are kind of easy, and today we're going to look at this idea of a ratio. Now, if you notice, I gave you the definition on your note sheet. Okay, a ratio of one number to another is the quotient. Okay, the quotient when the first number is divided by the second number. Now, again, we're talking about quotient. We're talking about division. All right, and we're going to see then that in our mind, in algebra, now that we're in algebra, how do we write division? That's right, we're going to write it as a fraction. Now, if you look on your note sheet, there's actually 3 different ways that we can write a ratio, and I usually go toward the way of fractions. So let's look at our first 2 examples here. It says write each ratio in simplest terms. So we can write it as the colon. We can write 32 and then put the word 248. The other way is write it as a fraction, and that's pretty much the way that I prefer since we're in algebra. Now, basically we're just simplifying or reducing that fraction. Okay, what's the GCF? What goes into both of those? Yeah, I agree, 2. There's a bigger one. 4. There's a bigger one than 4. Has anybody figured it out yet? Yeah, we're going to see my GCF here is actually 16. So if we divide both the numerator and the denominator by 16, again, realize actually, this equals 1, and we're going to get 2/3. Now, remember, it's algebra, so they're going to throw in letters and numbers. So let's go ahead and take this as it's written, and let's write it as a fraction. We've got 8a squared b over 2ab squared. So we're just going to divide. Remember, let's look at the numbers. Well, 8 divided by 2 is 4. Now, if we look at the a's, we've got a squared divided by a. Remember, we subtract our exponents and we put the answer back where the bigger exponent was. So we're going to have a in the numerator. And then when we look at our b's, same idea. We subtract our exponents and we put the answer back where the bigger exponent is. So that's how we simplify those ratios. Pretty easy. We're just simplifying fractions. Okay, now they're going to let us use some ratios, okay, for us to compare units. Now, you can use ratios to compare 2 quantities of the same kind. Big important thing to remember. First, you have to express the measures in the same unit. So you've got to really be paying attention, and then you write your ratio. So if I look at our first problem here, I've got 5 days to 18 hours. Now the problem there is they are not the same unit. So which one is it going to be easier to convert to? Yeah, that's right. I'm going to change 5 days to hours. What's my conversion factor? Well, I know 1 day has 24 hours. And again, we're going back to dimensional analysis or unit analysis that we've seen before. All right? And so if we take 5 days times 24 hours, well, what's 5 times 24? Yeah, looks like that's going to be 120. So we've got 120 over 18. All right, so now how do we simplify that fraction? Okay, what goes into both of those? Well, the easiest way would be 2. We right here could say our GCF is 2. And so if we put 2 into both of those, we're going to get what? 60 over 9. Okay, my GCF is 2. Do I have another GCF here? What goes into both of those? Yes, 3 will go into both of those. So if we divide both of those by 3, what do we get? 20 over 3. And now that's our final answer. We've simplified our ratio. So again, we're talking about ratios. We're just talking about dividing two numbers, the quotient of two numbers. Again, the easiest way for us to write that for algebra, okay, is the idea of using the fraction bar. And we're just simplifying fractions. Okay, let's look at our next situation. We're going to look at example 5 in your book. You're on page 288. Now they're going to throw in some story problems. Now here's the deal. If you look at my little hint here at the top, the man with the hand, here we go. All right, you may need to express a ratio in a different form. If numbers are in a ratio of 3 to 5, then let 3x and 5x represent them. So let's look at example number 5. We're on page 288. And it says, Jeff planted alfalfa and wheat on 160 acres of her farm. If the ratio of acres of alfalfa to acres of wheat is 3 to 5, how many acres of each crop are planted? Now, it's real important to keep up with the order. It's alfalfa to wheat. So that means alfalfa is the first number and wheat is the second. Now, since we're doing a story problem, the first thing we need, okay, we need a let statement, okay? And since my ratio is 3 to 5, I'm going to let 3x equal acres. And what was 3 with acres was alfalfa. And then the 5x goes to acres of, the 5 in the ratio went to, the second word mentioned was wheat. Okay, so there's my let statement. Now let's take that let statement and make an equation. It says if the ratio is 3 to 5, how many acres of each? All right, so we know that she planted 3x of alfalfa plus 5x of wheat. What was the total amount of acres she had on her farm? Yeah, 160. And so now we're back in chapter 3. What do we need to do first? Combine like terms. 3x and 5x is 8x equals 160. We got to get x alone, so we divide both sides by 8. So what does x equal? Yeah, when we look there then, x equals 20. Now we solved for x, but did we answer the question? How much of each? Well, we know alfalfa was 3x, so that's 3 times 20, which is 60 acres. Okay, wheat was 5x, so that's 5 times 20, which is 100 acres. And again, remember, since you were doing a story problem, I need a check. And if you add those together, we get 160 acres. And that is my check. Okay, the 5-step plan is still in play. All right, now, there is one little tricky one. If you look at the problem on your note sheet, if you look at the problem on your note sheet, it says, now look at example 4 on your note sheet for 7-1. And if you're looking there, it says write the ratio of wins to losses for a baseball team that played 72 games and won 45 of them. So if you notice, it says they want the ratio of wins to losses. Now I'm going to go ahead and get rid of this so we can talk about it. So we want wins to losses. All right, I guess I should say plural, wins. All right, so when I look there, it says that they won 45, but they played a total of 72. So I know I have 45 wins, but I don't know what my losses are. Can you think of a way with the information that they gave me that I can find the losses? Let's read it again. Write the ratio of wins to losses for a baseball team that played 72 games and won 45 of them. Yes, that's right. To find the losses, we're going to take the total number of games they played, which was 72, and we're going to subtract how many they won, which was 45, and so we're going to get 27. So our ratio is 45 to 27. Now, again, you can write it with the colon, or we can write it as a fraction. I like the fraction. So if we write 45 over 27, can I reduce that fraction? Does anybody see my GCF? Yeah, my GCF is 9, so this would simplify to 5/3. Good job. So sometimes they don't give us the numbers right out, but they give us enough 411 for us to get there. All right, now let's look at one more type of story problem. One more type of story problem, and then I'll let you start homework for today. So if you're looking here at our last slide, okay, it says the heights of 3 brothers are the ratio of 13 to 14 to 15. Their combined height equals 210 inches. Use the 5-step plan to find the height of each brother. So again, you know that whenever we're doing story problems, we're using the 5-step plan. So what are our unknowns? Well, what do we have to find out? We have to find 3 brothers' heights. And again, you remember, we kind of roll step 1 and step 2 in together. Now, where am I going to get my let statements from? Remember, defining the variable means my let statement. That's right. We're going to go back up here and we're going to use this ratio. We're going to use that ratio to get our let statements. Okay? We're going to let 13x, 14x, and 15x equal the heights of the brothers. And so now we're going to use those 3 let statements in the equation. What's the other important piece of information we need? Yeah, did you see their combined heights equal 210 inches? So we've got 13x, the first brother, plus 14x, the second brother, plus 15x, the third brother, and their combined heights equals 210 inches. So that's our equation. Now, how do we solve the equation? Yeah, did you see we've got a lot of units to combine, like terms to combine. If you add all those up, okay, we're going to get 42x equals 210. And to get x alone, remember, isolate the variable by inverse operations. We divide both sides by 42. So x equals, everybody says, 5. Now, once again, we solved the equation, got that, but now we've got to make sure that we answer the question. What was the question? We got to find the height of each brother. Okay, so let's check it out. Well, 13x, 13 times 5 is the first brother, and so we're going to get 65 inches. Okay, brother number 2 is 14 times 5. And so that's going to give me 70 inches. And brother number 3 is 15 times 5. And that's going to give me 75 inches. Now, what's going to be the easiest way to check? Good job. We're going to add all those together. And if we do, we get 210 inches. Great job. So tonight's homework, section 7-1.